Hey geometry students, Mr. Rising here again. This time I've got the American flag. I'll get that right someday. Look at that. American flag right there. And the UAS banner right there. I've got a ruler. I've got a protractor. I'm ready to go. Today we're talking about angles. And when we're in class, we're going to use some tools together, including the compass and the protractor and a straight edge. But we need to just talk a little bit about theory. So the objectives for today, we're going to be naming and classifying angles and measuring and constructing angles and angle bisectors. This part we're definitely going to do in person, but this other stuff we can talk about over the computer. Vocabulary, as we go through, if you don't have your vocabulary terms already written into your notes, you want to get these in here. We're going to be talking about all of these terms, from angles to congruent angles and angle bisectors. But otherwise, sit back, relax, take some notes, and here we go. So an old-fashioned tool used for measuring angles was called a transit. And later in the course, you're going to actually build one of these. And it's a really cool tool that surveyors have used for a long time, and map makers, explorers. The big idea here, though, is an angle is formed by two rays or sides with a common endpoint. So anytime you've got two things coming together, you've got angles, right? Think of your arms, think of whatever you like. So the common endpoint is called a vertex, plural is vertices, and you can name angles several ways: by its vertex, if there's only one angle, by a point on each ray and the vertex, or by a number. And I'll show you some examples here. So one more little bit of theory. The set of all points between the sides of the angle is the interior. So everything within these sides is the interior. All the points on the outside, I love this little drawing, right? The little purple blue, shading, is the exterior. So ways to name this. You could say this is angle R because we're only referring to the interior angle. You could also call it angle, and there's the symbol SRT. The vertex always goes in the middle. Or you could call it angle TRS. Or you could call it angle 1 because they put a little number there. And again, you can't just name it by the vertex if you've got multiple angles. Okay? So let's try this one. A surveyor recorded the angles formed by a point, transit, point A, and three distant points, B, C, and D. Name three of the angles. Well, they don't give you any numbers, so go ahead and try this. Pause. Okay, what'd you come up with? So you've got angle BAC, you've got angle CAD, and you have angle BAD. Now, if you said DAB, that's fine. If you said CAB, that is also fine. But those are the three angles that we're talking about. You can't, again, just say angle A, because we're not sure if that refers to this angle A, or this all-encompassing angle A. All right, write the different ways you can name the angles in this diagram. Go ahead, I'd like you to try this, pause the video, and see what you come up with. Okay, welcome back. So, what did you get? You should have come up with something along these lines. QTR, now I don't have the angle symbol, so I'm just using this symbol on my keyboard. QTR, so QTR. How about a non-black pen, Mr. Rising? Non-black pen. Ooh, hot pink with dashes. QTR. Look at that. Oh man, that's gorgeous. QTS, right? RTS. Oh man, hot pink. I love it. And angle 1 or angle 2. Again, if you said STR, that's fine. You don't have to label it again once you've defined that this is an angle. But when you have numbers, obviously angle numbers are much easier to work with, period. The measure of an angle is usually given in degrees. So think about that. On my typical protractor, I've got 180 degrees. It is written both on the inside, going from counterclockwise, and then on the outside, counterclockwise, if that looks right for you, going from 0 to 180. So when you think about that, there's 360 degrees in the circle. 1 degree is 1/360th of a circle. Okay, so protractor, given line AB and a point O on AB, all rays that can be drawn from O can be put in a 1-to-1 correspondence. Now, you have used these tools before. We're going to review this a little more in class because it's hands-on. But the key here is that you know how to read it, right? When you have a point, you could say, for example, point D over here. Well, it's either at, you could say this is at 65 degrees if you're reading from clockwise, right? In this direction, it's 65 degrees on the mark. If you're reading from the other direction, which is also fine, you'd say, well, no, that's actually 115. I don't know if the yellow shows up. You'll have to let me know later on. Say, hey, Mr. Rising, re-record that. I can't see the 115. So anyway, this could either be the mark of 65 or it could be 115. But however you read it initially, you need to read the rest of your coordinates that way as well. So if I'm trying to measure from AOC, A could be at 0, C could be at 45, so it'd be 45 minus 0, of course, is 45. So we're always taking the absolute value, just like length. Angle measures are always positive unless we're talking about angles of declination. We'll talk more about that later in the course. You're probably already familiar with these. Acute angles are between 0 and 90. Right angles are exactly 90 degrees. Lots of special properties with these. Obtuse angles are greater than 90 but less than 180. And a straight angle is formed by two opposite rays, and their measure is exactly 180 degrees. Make sure that these terms are listed in your definition section. Okay, cruising on. Find the measure of each angle, then classify each as acute, right, or obtuse. Go ahead and try that. All right, what'd you come up with? First of all, y, x, z. So is 50 degrees. I'm reading, in this case, clockwise. So from 0 to 180, and I'm using the outer band. You'll get the same answer if you do it the other way. If you go from counterclockwise, starting on the inner track. It doesn't really matter so long as you're consistent. Z, X, W. Of course, I've got 150 here at W. Z's at 50, so 150 minus 50 is 100. That's obtuse. And here's a couple of. There are more angles here. I didn't include all the angles, but if you tried any of these, so that was either WXY or YXW, you should get 150 degrees in obtuse. A few more examples here to try. Go ahead and pause the video and try them all. All right, BOA is a 40-degree acute angle. DOB is a 125-degree obtuse angle, and EOC is a 105-degree obtuse angle. Mr. Rising's getting a little faster. I hope you appreciate that. Okay, big stuff here. Definition and important concept. Congruent angles are angles that have the same measure. Congruent angles are angles that have the same measure. So you'll notice these little tick marks. So what we would say here is angle ABC is congruent. This symbol again means congruent to angle DEF. These tick marks indicate that these two angles are congruent. If you had multiple angles that were congruent on the same page, well, maybe you'd have two sets of tick marks. You'd say, okay, well, these two, right? These angles are essentially a pair of congruent angles. They need to have the same number of arc marks. Angle addition postulate is very similar to segment addition. You've been doing this since you were little. I mean, you're saying, hey, this plus this is the whole, right? And that's what we're saying here. Because QS lies in the interior of angle RQP, that means that the measure of angle RQP is the sum of the measure of angle RQS and the measure of angle SQP. Please put this postulate in your theorem section of your notes. All right, let's just try this concept. So when we say, hey, the measure of DEG is 115 and DEF is 48. I like to label things so I know what the heck I'm talking about, because it's, with all these letters, it's very easy to get confused as to which angle is which based on the numbers. So kind of the obvious question is, well, then what's the measure of this angle? Well, if we subtract 48 from 115, we'll get that measurement. If you want to see the broken down algebra, I like to do it this way. DEG is 115, DEF is 48. When I subtract the two, I get 67. Here's another problem. I think you get the idea. I'm going to move on to angle bisector, another key vocabulary term. A bisector is a ray that divides an angle into two congruent angles. I'm already at 11 minutes, so I better wrap up here in just a moment. I'm going to do that here shortly. So what we're saying is JK bisects LJM, therefore, thus, LJK is congruent to KJM. That's what it means for an angle bisector. So when you have a problem like this, it says KM ray, KM bisects JKL, okay? That means this is congruent. Let's just mark that. That way we know right off the bat, hey, this angle here is congruent to this angle here. And notice I didn't just put a line straight across the two, an arc mark. That way it just, I'm separating that. It kind of makes it clear. I know these two angles are the same. So when you want to solve a problem like that, set them equal. The measure of JKM is equal to 4x plus 6 degrees. And the measure of MKL is 7x minus 12 degrees. Find the measure of JKM. I am not leaving this problem until I find the measure of JKM equals. It's a great idea to just write this out somewhere right off the bat and say, hey, I am not leaving this problem until I fill in that space. Let's try it. So set it up. Angle JKM equals MKL. Now I'm substituting the algebraic expressions for both. Okay, subtracting both sides by 4x and adding 12 to both sides. Simplify my math. 18 equals 3x. Divide both sides by 3. X equals 3. Am I done? No, I'm not done, because I didn't answer my question. My question was, what is the measure of JKM? Which means I have to go in here and substitute. Hey, stop doing that. Let me just move this out of the way. I have to substitute this 6 into this original expression. So 4 times 6 is 24, plus 6 is 30. I also double checked it. I could plug 6 into this expression. 6 times 7 is 42, minus 12 is 30. So, hey, let's just do it, right? Let's just write in here, I know this angle is 30 degrees. I'm already at 13 minutes, so let's just move right along. There's explaining it out. And really, that's it. Don't worry about this homework. We're going to try this another time, or I'll give you a different assignment. Hope that helped you understand what angle measures are, how to use a protractor, and of course the big concept here is angle addition postulate and angle bisector.